All right, so here's the bioman cell membrane or cell defense. I'm gonna do a little different this time. So here's your worksheet. When I get to this, first I'm gonna go, you go to here and you do the little simulation, it takes you to here. But when I get to this, most of these blanks, I'm gonna say the answer. I'm not gonna type it. Now, if it's a hard word to spell, I'll type it for you. If not, I'm just gonna say it. So if you're sitting around, you're just gonna talk or play on your phone, and you're going to wait for me to type and you're only going to type what I type, congratulations, you're wasting your time. You might as well stop this video right now because I'll give you a 0 if you type just what I type because it ain't going to be much. All right, so first I'm going to do this. All right, so start a new game. Plasma membrane, same thing as the cell membrane. It's like the skin that goes around all of your cells. Build a membrane. All right, so right here, all living cells depend on the plasma membrane or the cell membrane to regulate what comes into and out of the cell. So it controls what comes into the and out of the cell. Without the plasma membrane or cell membrane, the cell's going to die because it will be unable to maintain homeostasis. All right. So I'm going to try to go as quickly as possible. Sometimes this thing don't really cooperate. All right. Because there's so many pop-ups. I hit a pop-up. Yay. Gosh, get these pop-ups out of here. All right, space. All right, first, cell membranes are made of phospholipids. The balloon part is a phosphate. It's hydrophilic because it loves water. Now the strings part, those are lipids. They're hydrophobic because they hate water. All right, well, we'll get to that later. You don't need to know anything of that. All right, boom. Here's my lipid bilayer. Just got destroyed by somebody. A bunch of water, H2Os. So first I got to fix it. I'll try to fix it as quickly as possible. So you can see the phosphates are facing towards the outside of the cell and towards the inside of the cell where there's water. Because remember, the balloon parts, those are hydrophilic. They love water. The middle part, those red tails, those are hydrophobic. They hate water, so they stay away from the water. Got to flip these guys around, get the lipids. All right, so I got to fix my cell membrane that the guy screwed up. And I think that's good. My membrane is ready. I look, the water cannot go through the lipid bilayer because water is polar and the lipid tails block the water from crossing the membrane. All right, so now it says my membrane is unstable. I got to stabilize it with these cholesterol molecules. You won't need to know this. I'm not really concerned too much. This helps to stabilize and helps to keep the cell membrane kind of intact. I don't know how many I need. I guess that's it. 4. All right, so I stabilized it. I know. Look what can go through. Look at the gases, CO2 and O2. Boom! They go right through the lipid bilayer, right through the phospholipid bilayer. They do not need a quote unquote door or a protein channel. The ions, the negative and positively charged ions, and this glucose sugar, they cannot go through. Cell membrane blocks them. Observation is complete. All right, so what could easily pass through the cell membrane? CO2 and O2. Boom. What could not pass? Because remember, the cell membrane is semi permeable or selectively permeable. Some things can go through, like CO2 and O2. Other things are blocked, like ions and glucose sugar. Boom. All right, so to get those other things in, we need doors. And this is a protein channel that's going to allow things in. So this is going to allow the ions in. So I'm going to put a couple of them to get them in here as quickly as possible. So these things cannot go through the balloons and strings. They need a door. I can't move this guy for some reason. Ah, I can move this guy. Boom. This guy's stuck. All right, this ion's going to go in there. Oh, it missed it. Oh, well, now it's even. So they only move until there's equal amounts on each side. All right, there were equal amounts on both sides, so that's good. So remember, in passive transport, like diffusion and facilitated diffusion, I know you don't know what all these are, things move from where they're in high concentration, a lot of them, to where they're in low concentration, very few of them. And we're going to go over this a lot more. All right, so sometimes a cell, blah, 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 blah. All right, let's go. All right, so sometimes things want to move from low concentration to high concentration. The molecules don't want to do that. So the cell is going to have to make them move. And when you make them move, it's going to require energy. That's going to be called active transport. All right, so for this, To get these ions, oh, it's another channel protein. So we're gonna boom. Oh, okay, here. So this is a pump. It requires ATP. That's the energy molecule. So it's gonna take energy to move these guys across the membrane. Boom. 'Cause look, it's a high concentration down here. There's one, two, three, four, five, six, seven down here. There's only three up here. So these guys don't want to move down there, but we're making them move. And this requires what's called ATP energy. And that's called active transport because they're being pumped against the concentration gradient, which just means they're going from high to low concentration. They're moving from where there's few of those molecules, and the cell is moving them to where there's a bunch of those molecules. All right. You must master one final molecule to understand carbohydrates. You're not going to know this. I'm not really concerned about this. All right. So your cell has proteins and carbohydrates on the outside, and they're kind of like name tags. Now look, here comes an immune cell, a white blood cell. He's looking, he wants to see, he goes, this cell belongs here. It's not a foreign invader. That's like a little name tag that says, this cell belongs in your body. It's not like a virus or bacteria. I understand. All right, so next one we have to do is the energy transport challenge. My goal, I think, is to transport 10 sugar molecules across the membrane into the cell using as few ATP as possible. ATP is the energy molecule. So I gotta make sure I move these molecules. When I use ATP, it's gonna be going against the concentration gradient. It's gonna be going from low concentration, very few glucose molecules, to high concentration where there's a lot of them. All right, so let's see where guys as cross as I can. Now, when there's even amounts, there's one, 2, 3. There's one, 2, 3, 4, 5, 6, 7. All right, so there's 10 total. So now there's 4 on the bottom. Now there's 5 on the bottom. Now it's even. They're not the channel proteins are not going to work anymore. Now I got to pump them. I got to pump them across. Now look, when I pump them across, now it's take ATP energy because these guys, these sugars don't want to go down there. They're like, there's a bunch of sugar. We don't want to go down there. It's too crowded. So now it's going to require energy to move these guys. Oh, I got it. Didn't go. Oh, there it went. All right. So now look, there's one, two, three, four, five, six, seven, 8. These guys are like, we don't want to go down there. There's too many of them down there already. But I'm going to make them go down there. And since I'm making them, it requires ATP energy. This is called active transport because it's requiring energy. And the last one, boom. So I use 5 ATPs. Good job, it says. Next challenge. All right, the movement of a substance down its concentration gradient from high concentration to low concentration. That's what molecules want to do by themselves. They'll do it all on their own. So the cell does not have to use any energy. So that would be called, oh, through a protein channel. Ooh, all right. If it needs a protein channel, it's called C, a facilitated diffusion. If it goes straight through, like how oxygen and CO2 went straight through the lipid bilayer, that's just diffusion. But if it requires a door, a protein channel, then it's facilitated diffusion. The movement of substance against its concentration gradient. This time from low to high concentration through a carrier protein. Now this time you have to move them where they don't want to go. So you got to force them to go. Since you got to force them, you got to use energy. Guess what? Whenever you use energy, you're active. So right now, if you're actually watching and you're typing or writing or whatever, you're being active. You're using energy. So that's active transport because you're using energy. Ah, wow. If the sugar concentration in a cell is 3% and the concentration in the cell's environment is 5%, how can the cell obtain more sugar? Hint, sugar is polar and does not pass through the phospholipid bilayer. All right, so if it's 3% inside the cell and 5% outside, they'll go straight in. So they can use facilitated diffusion. Sugar can undergo facilitated diffusion. So it should be B. Let's see if I'm right. Yay. I'm right. Boom. Next question. Gosh, these are so long. If the sugar concentration in a cell is 4% and outside the cell is 2%, so it's a high concentration inside the cell, a low concentration outside the cell. How can we get more glucose in? Now the glucose does not want to go in. So we're going to have to force it in. We're going to have to use energy. So the cell must use active transport to pump the sugar in. That should be correct. And it is. Because whenever you're moving them from low concentration to high, It requires energy. If it requires energy, that's active transport. How many questions are we going to have? Oh, good. That's it. All right. The last one we have to do is the osmosis challenge. Osmosis is the movement of water across a semi permeable membrane. So, water. The movement of everything else is diffusion, but the movement of water is osmosis. So, let's go ahead and do it. All right. So, water is going to move from high concentration to low concentration until it balances out. Don't need to replay it. So look, there's 1, 2, 3, 4, 1, 2, 3, 4. So the movement of water across a membrane from high concentration to low concentration, it's a form of passive transport because it does not require any energy. Boom. La, 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 la. Notice that if there is more solute, then there is less water, and if there's less solute, then there's more water. All right, you guys are not going to understand this right now, but you can see this. See how there's 3 solutes over here? So that means if there's more solutes, we could say it's like salt. And over here, there's like only one little piece of salt. So there's a higher concentration of water over here. Over here, there's more salt, so there's a lower concentration of water. So water is going to want to move this way from high concentration of water to low concentration of water. There it is. Look, because there's only one little sugar in here. There's 3 in here. So everything in nature wants to move from high concentration to low concentration. So the water, these little blue circles, are going to want to move this way where there's less water. And that's it. Oh, hypotonic, hypertonic. We'll go over that later. All right. So aquaporin. This is a special protein. If you guys speak Spanish, aqua, that means water. Porin is like a hole. So this is like a hole or a channel that allows water to move in and out. All right, so I can't let the cell get dehydrated. I haven't even done this in a year, so I need good luck. Let's see. All right. I don't know why it won't let me drag some of these. Say I gotta get sugar equal on both sides. Once we get sugar equal on both sides, 1, 2, 3, 4, 5, 6. I need to get one more down there. Boom. All right, that should keep the cell from being dehydrated because now we have equal amounts of sugar on each side. 1, 2, 3, 4, 5. I'm gonna leave that guy right there. 1, 2, 3, 4. Oh wait, 4. Maybe I get one more down here. Now there's 5 and 4. All right, so look at the water. It's going through the aquaporins. Now there's more sugar down here. That might screw things up. Hopefully it doesn't. I can't move them back though. Let me get these things out of here. I don't want any more to go. So we use 6 ATPs. And if anybody knows what to do, don't let that cell get dehydrated. But if I keep moving sugar in, water's going to keep moving in. Let's bring them in. Let's see what happens. Let's move all the sugar in. I guess maybe that's what it wants me to do. The cell's definitely not going to get dehydrated, but all these waters are going to start moving in. All right, now there's a low concentration of water out here and a high concentration. So water's going to move in because there's lower concentration in here because there's all this sugar. Good job, I guess. Honestly, that's kind of worthless. So, all right. We're not going to need to know that. So, all right. So now we're going to do the worksheet. Remember, most of these blanks, I'm not going to type. I'm going to say it. So you're going to have to listen to my little story. I don't want to listen to your story. Well, yeah, you got to do it if you want to get the answers. All right. So Dr. Vile has a weapon that destroys plasma membranes. That's cell membranes. That's the thing that covers all of our cells, goes around all of our cells. Without cell membranes, right here, cell membranes, cells of living things will die because they are unable to maintain homeostasis. Remember, homeostasis is keeping like a balance within your cells or within your body. So we need cell membranes to maintain homeostasis. Okay, zoom in on the plasma membrane. From the urgent message, you learn that phospholipids are okay, I'll type this one. Remember, if you're just typing what I'm typing, you're wasting your time right now. It's made of a phosphate head, and this is easy to spell, so I'm not going to type it. Lipid tails. So the balloon part, the little circle part of a phospholipid is a phosphate. And the little tails, the little strings, those are lipid tails. All right, this one's kind of hard to spell again. So the heads, the phosphate part, are called hydrophilic. Did I spell it right? Yes. And hydrophilic means loves water. So right here, put loves water or water loving or likes water, whatever you prefer. The tails are hydrophobic. If you have a phobic, it's like if you're arachnophobia, you're scared of spiders. Hydrophobia means like you're scared of water. So it means doesn't like water or hates water. So right here, you're going to put like hates water, doesn't like water, whatever you prefer. All right, repair the phospholipid membrane. Remember something shot through the membrane, made a hole. I don't remember exactly. But I think it was 6. All right, I'll type it for you. I'll put 6 on that one. What did I have to put in the membrane in order to stabilize it, to keep it in order, so it doesn't flop around too much? Cholesterol. I'll do that one. Cholesterol. You won't need to know that, so I'm not really concerned. How many did I add? It was 3 or 4. I was adding the 4th and it quit, so I'm going to say 4. What is another word for selectively permeable? Permeable means things can go through it. So if it's fully permeable, everything can go through it. If it's impermeable, nothing can pass through it. If it's selectively permeable, some things can move in and out, go through it. Other things get blocked. So another word for selectively permeable, you're going to write it right here, is semi-permeable. I'll write semi for you. Semi. But you got to add the permeable. So write permeable after semi. What does selectively or semi-permeable mean? It means, I'm just gonna say it because it's easy to spell these words. It means some substances can pass through the membrane freely while other substances are blocked. So some things can move in and out through the membrane freely and other substances are blocked. You need to write that right here. What two molecules easily could pass through the membrane? The two molecules that could easily pass through the cell membrane, they didn't require a protein channel. That was oxygen, O2, oxygen gas is O2, or carbon dioxide, CO2. So you need to write that right here. O2, CO2, or oxygen, carbon dioxide. What three molecules could not pass easily through? We're going to go 2. Ions and sugar. Ions and sugar could not go through the membrane because ions are charged. They're positively charged or negatively charged, and the cell membrane does not allow those to go through. Glucose can't go through because it's polar, and the lipid tails in the cell membrane they're non-polar, so they don't allow glucose sugar to move through. So on this one, the molecules that cannot go through, you're going to put ions and sugar. What does it mean when a molecule is said to be polar? I'm going to type this one because we need to know this. We should know it already. Polar molecules have a positive section and a negative section. So, so polar molecule, part of it is positively charged, another part of it is negatively charged. All right, insert a protein channel. We already did step 8. All right, I'm gonna type this one out. So remember, oxygen and carbon dioxide, O2 and CO2, they can go directly through the lipid bilayer, the 2 layers of balloons and strings, the yellow balloon and the red strings. They don't need a quote unquote door to get in. But sometimes things need a channel protein to go through. They need a door to get in and out. Whenever things need a door to move from high concentration to low concentration, that's not diffusion because oxygen and CO2, they go through the lipid bilayer. That's diffusion. But if it needs a door, that's called facilitated diffusion. It's kind of the same thing. It still goes from high concentration to low concentration. High concentration means there's a lot of that substance. Low concentration means there's fewer of that substance, and things always want to balance out. So the high concentration wants to move towards the low concentration. And if it uses a channel protein or a protein channel, that's facilitated diffusion. All right, on 9, this is where we're going to get into what's called active transport. When things are moved from low concentration, where there's few of them, to high concentration, so you're going to put low to high, or you can just put an L to an H, concentration. This requires the use of energy to move substances. This is going to be called active transport. All right, so once again, whenever you move something from low to high concentration, those molecules will not do that by themselves because they're going to want to balance out. They're going to want to equal it out. They don't want, the molecules where there's few of them don't want to move to where there's a lot of them. They just don't want to do that. So in order to do that, the cell has to force them to do that. So that requires the use of energy, right here, energy. And whenever you use energy, that's called active transport. So right now, if you're actually listening and typing, you're using energy because you're being active, active transport. I'm not really concerned about this one. Carbohydrates are like identification badges. Cells that have different membrane carbohydrates do different, I'm just going to type these, do different jobs. The immune system uses carbohydrates to, what should we say, determine that your cells belong to you and are not like foreign invaders like bacteria or viruses or other foreign cells. So your immune cells, they see these little carbohydrates and proteins on the cell membrane, and they determine whether those cells belong to you or not. And they're not like a bacteria or a virus, because if it's a bacteria or virus, your immune system is going to fight it, to make you healthy again. So what does the immune system do to foreign invaders? Put right here, it fights the foreign invaders. So your immune system, your white blood cells, fights the bacteria and the viruses. So if you get sick, your immune system fights those guys, and then you're not sick anymore. What kind of cell does this? Right here, you're going to put white blood cell. White blood cells are what does this. Those are your immune cells, white blood cells. All right, here, when we did the energy transport challenge, I believe it took, I think it was 5 ATPs. Remember, ATP is the energy molecule. ATP is whatever you're doing, whenever you need energy, ATP is always the molecule that gives you that. We haven't gone over ATP yet, so I'm not too concerned. What type of proteins were used? All right, so we had 2 types of proteins. I'm going to type these. We had channel proteins, and I'm going to put protein pumps. And remember, once again, if you're leaving all these blank, and you're just typing in the ones that I'm typing, you're wasting time because I'm not going to give you credit for it. All right, so where are we at? Immune system fights them. What kind of cell does this? White blood cells. All right, so I'll do this one. Channel proteins are for facilitated diffusion, and protein pumps for active transport. So the protein pumps, that's when you're moving things from low concentration to high concentration, because those little things are not going to go that way on their own. The cell's going to have to force them to go that way. It's got to pump them. So that's why it's active transport, because to pump them that way, it requires energy. Okay, what is osmosis? Right here. For this one, osmosis is the movement of water across a semi-permeable membrane. Once again, osmosis is the movement of water across a semi or selectively permeable membrane. What is the name of the special proteins that let water pass through? I'll do this one. Remember, water in Spanish is agua. Porin is like a little hole. So aqua. Wait, I forget how to spell it. Aqua porins. Boom. And is osmosis passive or active transport? Since water will move all by itself from high concentration to low concentration, it's not going to require any energy from the cell. Since it doesn't require any energy from the cell, in this one right here, you're going to type passive transport. Passive, Passive, transport. And don't worry about taking a screenshot. All right, so remember, we got to get all of these filled in if you want any credit of all. I did quite a bit of it. So, all right, thanks for watching, and I'll see you next week.